So now we're going to look at an example where our first term has a coefficient. The previous examples for our trick of factoring trinomials, that a was always equal to 1. We didn't have to worry about it. We just broke it up into x and x in each set of parentheses. But here we have a 2, so we're not going to be able to do that. We need a new method. The method we're going to use today is called Steve's method. It's important to note that Steve's method isn't actually good math while you're doing it. At any point in the process, you don't have this value necessarily, but the end result will be the factored form of this trinomial. So it's kind of like trusting the process as you go through it, and the end result will be what you want. So just follow the rules, follow the steps. Step 1, you take this 2 off of the x squared and multiply it, changing the 6 by that factor. So 2 times 6 is 12. Again, the 2 comes off of the front, the middle term stays the same, and the last term is now multiplied by this 2. Now, you'll notice we have a trinomial where a is 1. We don't have a coefficient. So we're just going to apply the trick we learned in the previous videos to factor this. So, what's the factored form of x squared plus 7x plus 12? What multiplies up to 12 and adds up to 7? 3 and 4. X plus 3. X plus 4. Again, this is a process. We're not done. Now what we're going to do is reintroduce this 2 in front of both of these x's. Again, this is not good math, it's just a step in this method. And now, to finish things up, we're going to look at each set of parentheses, and if there's a greatest common factor in that set, we're going to cancel it out. Is there a greatest common factor between 2x and 3? No, there's no GCF here. So that factor stays the same. Is there a GCF between 2x and 4? Absolutely, that 2, that's a factor here and a factor here. We're going to cancel it out. We cancel out a 2 from 2x, we get x. And when we cancel out a 2 from 4, we get a 2. Notice how we're not factoring it out. It's not showing up anywhere else. We're just canceling it. Again, this isn't good math, it's just processes that work. So our final result is here. We started off with a trinomial where a was something other than 1. We did a few processes and ended up at